Welcome to Mission 2, Lesson 3. Our goal today is to learn how to write expressions with multiple steps. Expressions are number sentences without an answer. We will know we have had success if we can complete Mission 2 of Lesson 3 on Zearn.org. In order to do this, it's important that we know a few terms that are often used. And so I've written down the first 4 here, and then we'll add the other 2 later. You need to write these down in a place where you're going to be able to refer to it and use it often. Pause here, resume when you have written these down. You might even want to use the back page of your exit ticket for today's lesson. That's page 78, which is Mission 2, Lesson 3. Okay, now that we have these written down, these 4 terms tell us about answers to different kinds of math problems. As you can see, a sum is an answer to an addition problem, such as 2 plus 2 equals 4. 4 is the sum of 2 plus 2. Difference is the answer to a subtraction problem. 3 minus 1 equals 2. 2 is the difference between 3 and 1. A product is a multiplication answer. 3 times 3 is 9. 9 is the product of 3 times 3. And a quotient is a division answer. 6 divided by 2 equals 3. 3 is the quotient for 6 divided by 2. Even if you feel that you know these pretty well, write them down. If you don't know them well, that's okay. The way that you come to know these is by using them over and over, which we're going to be doing. Write them down so that you can refer to them whenever you need them. So another thing that we're going to see in order of operation problems are the use of parentheses. And parentheses are used for a couple of reasons. One is they show what we are counting. Another reason that they're used is to show what is solved first in the problem. When you are solving a problem that has many steps in it, they have to be done in a certain order. Parentheses are the things that are done first. So a unit, as referred to in our Zearn lesson, is what is in the parentheses. Let's take a look at a problem. 4 times the difference of 15 and 3. So in here, I notice the word difference. Difference tells me I'm going to need to subtract. And it's telling me the difference of 15 and 3. So I know that I'm going to need to find the answer to 15 minus 3. And I want to know what 4 times this answer is. So if I were to do this and draw a model, my unit, 15 minus 3, is going to be multiplied 4 times. And if I wanted to write this in an expression in a number problem, I would be able to say, okay, 15 minus 3, whatever the answer is to this, is what I want to know what 4 times the answer of that is. So the difference multiplied by 4. I can also write this the other way, because we know with multiplication that it doesn't matter which number comes first when they're multiplied. So I could say 4 times 15 minus 3 in parentheses, because I want to know 4 times the answer to this. Both of these say exactly the same thing. And our model says the same thing as both of these. We call this an expression when we write it out as a number problem. And the fact that they can be changed around is called the commutative property. It just means that we are able to switch these around and still come up with the same answer. Now let's try another one that's a little different. We want to find out the difference between 6 tens and 2 tens. I'm going to start out drawing my model. You do as well. So looking at my problem here, I want to know the answer to subtracting 2 tens from 6 tens. So first I need to start with 6 tens. I have 6 places here, and in each place I'm going to have 10. But I want to know the difference between 6 tens and 2 tens. So I have 6 tens, and I want to know the difference between 2 tens. So I'm going to cross off 2 tens. So I had 6 tens, 6 times 10, and here are 2 tens, 2 times 10. And I want to be able to subtract them from each other. So if I want to take this and subtract the answer of this, I need to put these in parentheses so I know that they come first. And here is my subtraction telling me that I am going to subtract from this amount. Now let's compare some expressions. Let's compare 3 times 12. Let's compare 3 times 12 to 5 12s. We can do this without actually finding the answer to either one of these problems. 3 times 12 and 5 12s are both ways of saying multiplication. We're multiplying 12 in each case, and on this side we're multiplying it by 3, and this side we're multiplying by 5. Remember that your alligator likes to eat the biggest number. So I'm going to draw my alligator eating the 5 12s because 5 12s is larger than 3 12s. So I can say 3 times 12 is less than 5 12s. Let's try another. 6 times 3 and 6 3s. Which is larger? You'll notice this is saying 6 multiplied by 3, and this is also saying 6 multiplied by 3. 6 groups of 3s and 6 groups of 3s, which means they are equal to each other, or they're saying the same thing. Let's try one more. Nine tens and 8 times 10. Both are multiplying groups of 10. 10 is being multiplied by 9 over here and by 8 over here. Which is greater? You're right, 9 tens is greater than 8 times 10. There's quite a lot going on in this lesson, so it will be very helpful for you to be able to come back and take a look at this as you are working through your Zearn lesson. I would suggest watching this through, and as you get to each section, pause, finish that section on Zearn, and then you can come back and go on to the next section. Hope this helps.